Question 8 is a graph question. I'm not going to draw the graph myself. I'm just going to talk about lines of best fit. Please make sure your line of best fit actually goes through pretty much all the points. It was a curve and you could have gone through all of them. So don't do kind of missing it out, evening your curve out and leaving points at the bottom. And don't do the old train tracks kind of uppy downy curve. It's not shading. We want one smooth curve when you're drawing it. Estimating, that's fine. That was just reading off your graph. This very specific question here, what does the graph show about the relationship between temperature and time taken? Not enough to say inversely proportional because I don't know which one is inversely proportional to which, really, if you're talking about that. Is it that the lower the temperature, the longer the time? It's just not very clear. So really you've got to mention both the variables in your answer. What happens when one changes and how? And so the relationship between temperature and time taken. Now this is the independent variable. This is the dependent variable. This is what was measured, the time taken to disappear or suddenly turn blue. This is the temperature that was changed in the experiment. So what we want to say is that as temperature increases, time taken decreases. That is all you needed to say. Anything else was not really answering that question. If you answered in terms of rate, you've not answered the question. This is what does this graph show me? I could infer, therefore, that the rate is faster if the time is less. But that's not what that graph shows me, so you've got to be specific to that question. Particle theory and collision theory. So the next bit, increase in temperature increases the rate of the reaction. There were 3 marks available, but again, a little bit of specificity from some of you. So the first mark was for something that mentioned particles having more energy, or that they move faster. That is not 2 marks, it's basically the same mark. A lot of you wrote that they therefore collide more, but more doesn't tell me how fast they're doing it, and so therefore what we really want, which we always want for rates of reaction, is that they collide more often, or more frequently, or more per second, anything like that. Now that's only part of the story because this is about temperature. So any old rates question normally gives you marks for talking about frequent collisions, whether it be surface area or concentration. But temperature is even better than that. It not only makes them collide more often, but more collisions have enough energy because they've got that more energy from the increase in temperature, have enough energy to react, or more particles have greater than or equal to the activation energy. So that activation energy is that magic amount that they need, and at a higher temperature they're more likely to have it because they've got more energy overall. Something that must be kept constant, you could have lots of things for this. You could have concentration of solutions, volume of solutions, amount of solutions. We're only looking for it to turn blue, so temperature obviously is already being changed in the experiment, so it's not being controlled. Pressure is not going to affect this because it's 2 solutions, there's no gases involved. The size and the volume of the container isn't really going to affect it either because we're just looking for it to turn blue, we're not looking for it to do anything else.